8 tons, and then every day 25% of it is gone. So it's very, very, very similar. So we can treat it similarly. The last dosage is 8 tons, right? So we'll put that at the end right here. How much of the second to last dosage is left at that point? 8 times what?
1 minus...
Well, hold on. Just if how much is degrading every day?
5%.
So how much is left? 7. Yeah. Oh, you're going to do 1 minus 1/4. I see. So that's to the first. What about this one? What's the one right before that? 3/4 to the what?
0.
To the second, right? Because it's 2 have gone by. I'm doing it backwards here, meaning if you go all the way back here, what was it? It was 8 times 3/4 to the n minus 2, and then what's going to be there? 8 times 3/4 to the what? N minus 1. Do you remember this?
Yeah.
We had before, instead of 8, what was it? 250. Instead of 3/4, it was 0.04. We okay with this so far? Is this a geometric series? Yes. What's the A term? Be careful. What's the first term? What's the biggest one? 8. You look at it going this way. You look at it going that way. This is the last dosage. This was the first dosage, so to speak. What's the R value? What's the R? 3 what? So what's the sum going to be equal to? 8 over 1 minus. So it's 8 over 1/4, which is 32. Will it ever get to 32? You can keep on dumping pollutants into this lake, whatever it is, bay. You'll get infinitely close to 32 tons. Infinitely close. Infinitely close. After a long time, it keeps going down to almost a little bit less than 24 tons, and then you add 8. A little bit less than 24, you get closer. Right? That's what's going on. 250 was the example. Oh, you carried 250 in from the last example? Yeah, 250 was just the original example. 250 was just the original example. 31. It doesn't tell you that this whole thing is a geometric series. It tells you that it is a series, right? So what's the fake out here? 4. This right here is a geometric series. Let's just look at this right here, for example, for a minute. What's the A term? What's the R value? Y over 3. So the sum of this thing is going to be what? Y over what? Great. So if you had Y, you could plug Y in and get the sum of the sequence, right? You know that this converges because this is geometric right here if what is true? The absolute value of Y minus 3 has to be less than what? 1. So Y minus 3 has to be less than 1 and it has to be greater than -1. So Y has to be greater than -3 and less than 3. So this thing will converge if this is true. Are you okay with that? Does that 4 change anything about the convergence or divergence of this series? No. If you have an infinite series, it either converges or what? Diverges. If I play around with a finite number of the terms, does that change the convergence of the series? No, it does not. If you have something that's infinitely big and you take away 5 things, does that change anything about the size of that infinitely big thing? No, it does not. This one's a little cheap because it posts that 4 up there. Ian in last class asked me, couldn't you just make it more annoying by putting 4 in the middle? I'm like, yeah, I could. Am I going to do that? No, that's really mean of me. Like, theoretically, if this question's nice because you immediately see the 4 and you're like, that's not right. But where could I put the 4? Like right in the middle? That would just not cool of me. Or just like scramble the order? Like, no. Or like make the test harder by doing this in front of the board as you take the test. Like, put everything away except the pencil. Okay, kids, here you go. So we had this. 1, didn't ask anything, 1, 2, 3 over 2, 5 over 3, 8 over 5, 13 over 8. Nice. So you might have looked at it, and what's one thing someone noticed? Anybody notice one thing? I'll add in some things here. How about 1 over 1? Top is in the bottom. So you have 2, and then 2, and then you have 3, and then 3. So if you saw that, that's really the big observation, because how do you get a number to go down to the denominator of something? Reciprocal. What operation is that? Divide something into 1. Right. So let's flip this over. What's the opposite of 2 over 1? What's that? Reciprocal. Oh, 2/3, not opposite. Reciprocal. 2 over 3. 3/5. And what's this? 5/8. What is the difference between these two?
It's 1, 1.
What's the difference between these two?
1.
These two. These two. So if you want Sn, you take 1 divided by the...
Reciprocal.
No, 1 divided by the
minus
last term, and then what do? Add 1. This is a hard one. This is a hard one. I wanted to see what you could do with it. Oh, it's a hard one. This is a hard one. It's a hard one.
Wait,
If you take the previous term, what's 1 divided by 1?
can you also just take...
There are other ways to do it, I think, but I'm not. I have to individually check all of them because sometimes people find ones that work for like the first 4, but not the next
If
one.
you take the 2 numbers on the top,
The 2 numbers on the top. Or 2 numbers?
okay, so like
Oh,
2
that's
plus
what I
3
did.
equals 5.
Yeah, you can't do that.
Okay.
Because, like, how do you reference the numerator of Sn minus 2? Do you understand what I'm saying?
Oh, yeah.
You see what I mean? Like, you can't, so you'd have to do an operation to isolate the numerator, and that, my guess is you can do that. Not my guess, you can do that, but it's going to be way more convoluted.
That's what I tried to do.
Yeah.
I didn't even think about that. I just said the
No, it's fine. Like, this is elegant, but it doesn't mean it's easy to see. I like this one, though. It's pretty cool. What does the new series do? Converges. Converge plus converge is converge. What about converge plus diverge? Diverge. Diverge plus diverge. Diverge, yeah. If something blows up, it blows up, right? You can't control infinity with finite. That's effectively what it is. These are all basic rules. So what we're really going to look at is questions like this. We're going to ask questions, does this converge or not? And we can analyze these things in many ways. You're going to get all these different tactics to test for convergence. But just because you have the tactics doesn't mean you should forget basic logic. What I mean by that is this. Does this series converge? Let's say you're totally lost and you're like, I don't know what test to run. I haven't taught you any tests, so what could you do to start this? What would be a good thing to look at if you wanted to know if this series converges or not? What could you write out?
10 of the 12.
Yeah, 10 of the terms and observe what happens. What's the first term going to be? If n is 1, what is the first term?
1 minus 1 over e.
1 minus 1 over e. If n is 2, what does it become?
1 minus e.
Yeah, n equals 3.
1 minus
E cubed. Now, these terms right here, these are the successive terms we're going to be adding together. What does the sequence go to? As n gets bigger, what does the sequence tend to? What do these get closer and closer to? 1. Okay, so if the sequence is going to 1, what does that mean about the series?
It's going to.
If you look at bigger and bigger terms, 1 plus 1 plus 1, what's that mean?
It's
Diverge. Since the terms don't go to what?
0.
So the first thing that's requisite is that the terms have to go to 0. But just because they go to 0, does that mean it converges? No. We looked at a series before that doesn't. What's this one called right here? Does this sequence go to 0?
No.
Oh, yeah. Sequence, yes. The sequence does, but does the series go to 0? No. Tonight for your homework, you're going to prove it. You're going to prove why. But here's the thing. Each term gets smaller. It's not geometric, but each term gets smaller. If you add them all up, though, guess what happens? Boom, it gets infinitely big. You can make any number you want, any positive number you want by adding, well, not any one, but you can make as large a number as you want by adding those fractions together. So what's the first thing you test when you're given something to see if it converges or not? A series, I mean. Check to see if the terms what? Go to 0, right. You look at the limit as n goes to infinity. Does it go to 0? Yes. If so, continue. If not, what does it mean? Divergent. If it goes to a static number, -2 plus -2 plus -2 plus -2, diverges. It has to go to 0. But is it sufficient for convergence? No. You need more than that. But always check that. For example, I can guarantee on a test or quiz, I'm going to give you something that looks nasty, and you're like, okay, I have 7 different convergence tests. I have to run the first one. Look at it and be like, clearly doesn't because the terms go to 7. Always check that first. Always check that first. This right here, these terms right here, this sequence, what does it go to? The sequence. As n goes to infinity, what does this go to? Yes, the sequence goes to 0. But this series right here, it blows up. It diverges. Just because the terms go to 0 doesn't mean the whole series has to go to 0.
The series diverges.
Oh, don't, well, let's not go backwards. If it diverges, let's be careful about the individual elements, because basically anything can happen when it diverges. But let's look at this. There's one really, really, really important word in this. What do you think the most important word in that entire thing is on the board? What do you think the most important word is? By what?
Integral.
Nope.
Comparison.
Comparison. So this is what we're going to do here. This right here is a sequence. It's defined by 1 over n squared. 1 plus a quarter plus a 9. Is it kind of a harmonic? Yeah, what's 1 squared? 1. What's 1/2 squared? 1/4. 1/3. It's kind of the harmonic. Is it above or below the harmonic? These numbers are smaller than the harmonic, right? Do you agree with that? Or equal to. 1 is the same, but then is 1/4 less than 1/2? Yes. Is 1/9 less than 1/3? Yes. Okay, so it's less than that. Doesn't really tell us much, though. This right here is one way to visualize it. Let's visualize it one more way. A graph. What's the area of this first box? 1/4. Yeah. What's the area of that one? 1/9, 1/16, 1/25. Those are the first 4 terms of the series I just showed you, correct?
Yes.
You see this blue function right here? What's that blue function? 1 over x squared. Kind of looks like Riemann's sum, right? You know, even divisions right there, right? Let's say I added this whole thing up. Everything underneath the curve. Everything underneath the curve. Is that area going to be bigger or less than the area of these boxes added together? Bigger. Bigger, right? So let's say we figured out that the area of this area under the curve was, I don't know, 4. I'm just making that up. What does that tell you about this sequence? Sorry, series. It's less than 4, so it has to what? Converge. If you are less than a convergent, you are also what? Convergent. Conversely, if you are above a divergent, what are you? You're also divergent. Above an explosion, what do? You also blow up. Below, in this room, what are you in? You're stuck in this room. You can't get out of it. So if you're below a convergent, you are convergent. If you're above a divergent, you are divergent. The opposites of those don't work. Yeah. Below a divergent, what does that tell you? Nothing, right? So like, I'm below the harmonic. That doesn't tell me anything. Also, if I'm above a convergent, does that tell us anything? Nope. So below a convergent, good. Above a divergent, good. Everything else, inconclusive. So what do we do here? We need to run this integral. Does anybody remember what this type of integral is called right here? It's a specific type of integral. Anybody remember?
Improper.
Improper. Someone other than Tomas, can someone tell me why that's an improper integral?
Is going to the bound.
Yep.
From 1 to infinity.
Yeah, this is one of the improper integrals going to infinity. Do you remember doing these kind of? A little bit maybe? No? Tablet mode, tablet, flat. So can you plug in infinity into an integral? No. Is infinity a number?
No.
It's an idea. It's something you're tending towards. So you might remember doing something like this. The limit as b goes to infinity, integral from 1 to b of 1 over x squared dx. Anybody remember that? We will be covering this again. We're going back to 7.7 and making sure you can do indefinite integrals. This is one way to do it. You can do this, though. You can do this. This is the limit as b goes to infinity of 1 to b of x to the negative 2 dx. Raise your hand if you can tell me what the integral of x to the negative 2 is. Raise your hand. Oh, in the back.
-1 x to the
Yeah, negative x to the what? Yeah. It's going from 1 to b, the limit as b goes to infinity. Oh, nice. So now you just have to be careful of the negatives. I can't tell you how many times people mess up the negatives at this point. They do the calculus, and then it goes. So what does this mean? It's the limit as b goes to infinity of what? Negative what? What do you plug in? b to the negative 1 minus -1 to the -1. What's this? What's the limit as b goes to infinity of -1 over b? What's that?
0.
So what does this go to?
0.
So what does this whole thing equal?
0. 0. So it's just 1.
It's just 1. So what did we just show here? What did we just show? The area under the curve is what? So this area right here, See my shading? It's so good. My shading is so good right now. All this right here, what does that add up to? 1. But we know that the sum of these boxes is less than that, which is 1. So if it's less than 1, what do we know this sum has to be? Convergent or divergent? Is, what is it? Convergent. You're less than convergent. It converged to 1. The roof converged to 1, so the series has to converge as well. Do we know what this converges to? No. But do we know it has to converge to something? Yes. You will search for things, and this is called the integral test. This is called the integral test. It's this right here. If you have an explicitly defined series, run the integral, and this is what's cool about it. If it converges, the integral, then the series converges. If the integral diverges, then the series diverges. So, do you effectively just have to remember how to do integrals? Yes. Is it just one way to do integrals? No. There's lots of different ways to do integrals. Improper integrals, you've dealt with maybe a little tiny bit. We're going to review those. So don't worry if this is new to you. Improper integrals is something that'll be on the homework. I think it's either tonight or tomorrow. What about this? What does this say? For what values of p does the series 1 to infinity of 1 over np converge? P is a static, let's say, integer right now, okay?
Is it if p is...
Let's just do it like this, ready? Let's say p is 1. What is this if p is 1? What is that?
1 over n.
1 over n, right? So that's 1 over 1, plus 1 over 2, plus 1 over 3, plus 1 over 4. What's that called?
Harmonic.
That's the harmonic series, right? So if p is 1, it's the harmonic series. And what did I tell you? You have to believe it. It's divergent. Tonight for the homework, you will be proving that. There's a lot of different ways. It's pretty cool. It leads you through it nicely. So we know that if p is 1, what does it do?
It's the harmonic.
P equals 1, therefore harmonic, therefore what? Because Mr. Seamon told us so. Diverges, right? So do you want to guess as to what the set is? When does it converge? When does it diverge?
Well, it can't be negative.
Well, it could be, but then it would what?
It would diverge.
Yes, so what are you going to say here for your answer here?
It would be anything greater than 1.
P greater than 1 means it's going to converge. And P less than or equal to 1 meaning it's going to diverge. Exactly. Now the proof is not that bad, but I don't really want to go over it. You can read it on your own. This is it. It's from 7.6. You have to use improper integrals for it. It's very similar to what we just did, but with lots of generalization instead. You can read this on your own. I'm not going to ask you to do this out. You just get to know this. For P series, for series that are of this form, if P is greater than 1, it converges. If P is less than 1, it... Oh, not less than or equal to. What am I... No, that's right. Less than or equal to 1, it diverges. I'm right. Good. So that's what we get right here. Yay! Exciting. So exciting. Super exciting. Okay, so why don't you guys find a piece of the board with somebody you're not sitting next to right now, and do these. Let's say I want you to do, yeah, all 7. It is, but I want you to actually do the integral from 1 to infinity of 1 over x cubed dx. You got it. 5 and see where we get to, okay? So for 5, you're doing the integral from 1 to infinity of n over n plus, well, x over, whatever you want to call it. I like x instead. X over x squared plus 1 dx. That's nice. What do we do with this?
There's a rule.
There's a something. I mean, there's like limit as, well, I want to do limit as b goes to infinity of 1 to b of x over x squared plus 1 dx. Okay, what should we do? Any ideas? To the air, you sub. Now, your notation might be different. You might have used w, called it something else. This is what I do. Get used to it. You should be fine. Hopefully, it's not that different than what you've done before.
We write W.
No, that's totally fine. You can do that. That's okay. I can follow W. But this is what I like to do. Also, my U's sometimes don't look very good, so sorry. I say this. U is going to be x squared plus 1. So what does du equal? 2x dx. Remember that? So now you do the substitution, right? So if you do that substitution, be very careful. Limit as b goes to infinity. So we end up with x squared. Oh, what do we end up with on top? X over 2x. Oh, wait a minute. X over 2x. We have to be really careful about this, don't we? We want to do substitution first. Hold on. If this is that, what does dx equal? Du over what? 2x. I like doing it there, okay? This is what I like doing. So I just like setting the substitution up beforehand. So we have x on top, u on the bottom, but what goes out here now? Du over what? 2x? What can I factor to the front? Well, I can't factor x out. Those go away, right? But I can factor out a what? So I have 1/2, the limit as b goes to infinity, integral of 1 over u du. What have I not written in? I haven't written in my what? Bounds. Why haven't I written in my bounds? I was very, very particular about not writing in my bounds. They change. Number one way you mess up u substitution is you don't change your bounds when we change variable. Right. This right here, we have x values, right? Now we're in u values, right? So how do you change x into u? You plug it in there. So instead of 1 to b, it's going to be what?
So 1's going to be 3.
What's it going to be? 3? I don't think 3. 2. 2. And what's the top one going to be? And that looks nasty, but it doesn't really matter because b is going to what? Infinity. It's like really going to infinity. It's important to me that you notice that though. So I will highlight it here. Important and important, right? So we have what? 2 to what? B squared plus 1. So now what is the integral of 1 over u? Exactly. So you have ln of this going from 2 to what? B squared plus 1. So what do you end up with? Oh, sorry, taking a breath here. Need a breather.
Can we also put the x squared plus 1?
You could. I like it better this way. I like changing the limits and not doing the substitution at the end.
Okay.
You could resubstitute at the end to put it back in terms of x. I much prefer this because it's generally a lot faster. Generally. So what do we have here? ln of what? B squared plus 1. It's really positive, right? Yay, exciting. Minus what? ln of 2, like this. What does this go to right here? What does that go to? What's the natural log of a trillion bajillion plus 1? A big number. So this goes to what? So what do we have here? 1/2 of infinity minus ln2. I mean, that ln2 is really trying there. It's like super trying. It's super trying. It is losing. So what do we know therefore? It diverges. Do we have any idea what it adds up to? Do we have any idea what it adds up to? No, we just know it does not add up to a finite number. Yes? Okay, so if we jump to 7 right here. First, write it properly. Limit as b goes to infinity of the integral from 2 to b of 1 over x ln x squared, like this, dx. Excitement. Oh yeah, you should maybe, yeah. U is equal to what? ln of x? So du is going to be what? 1 over x dx. So what does dx equal? X du, right? So now if you do the substitution, you get, I'll stay in green. I'll try to stay the uniform color. Limit as b goes to infinity. What's it now become? ln of 2. And then what? ln of b, 1 over x u squared x du, right? Does something cancel?
Yes.
La! If that didn't cancel, you can't go anywhere. Ain't multivariable yet. We're not doing partials. We're doing single variable here. So what do we end up with? We end up with this nice, staying green, limit as b goes to infinity, integral ln2 ln b u to the negative 2 du. Is that something you can integrate? Hopefully. I mean, we already integrated it today, so maybe you remember it. Maybe. So you integrate this, you finish it. Anybody finish it? What happens to it? Does it converge or diverge? It converges, yeah.